Yes. Yeah. Um. Good day, everyone. You're welcome to my YouTube channel. This is a five-story building, a five suspended floor. G+5. We are going to be designing a pie foundation for it. Now, remember the last class, the last video that I just uploaded on my YouTube channel. I taught you guys the principles in the design of a pad footing. So for this structure now, we are going to be designing a pie foundation for this. So you can see that all the structural elements pass: the pads, the columns, the beam, the slab, everything passed. So um the the soil test was carried out on the soil where the structure is actually going to be built, and we got to see that we have a very poor soil there. And so the geotechnical engineer recommended a pie foundation for any form of structure that will be constructed there, even if it's a two suspended floor. So because we have a very poor soil there, it has a poor bearing capacity. So now, when you want to design a pie foundation on that structure, there are principles that you need to know, and there are some very important things that you need to know and that you need to adhere to during the design of a pie foundation on Prota. And like I said ab initio, it is very important for you to have the soil test report. Very important. In fact, if you want to do any form of structure, be it even was suspended floor, ask the client to carry out a soil test report so you can have an idea of the bearing capacity of that particular place. So a soil test report was carried out on this land, and this is the anticipated safe working load of the of the of the of the different piles diameter at their respective depth. So if I'm doing a pile diameter of 400, the safe working load is at 21 meters is 371. If I'm doing a pile diameter of 450, as you can see on the table, those are their various safe working loads. So if you don't carry out a soil test report, there is no way you would know what the various safe working loads are. Now, we are going to use the geotechnical information that we have here to design the foundation for the structure. The structure I showed you, like I said, is a G+5. Yes, it's a G+5. So we have five suspended floors, and all the structural elements have been designed. And as you can see that all the structural elements, but please, it is important that all your structural elements for the superstructure passes before you move to the substructure. It's very important. So now let's proceed to the structural design of the foundation proper now. So let's go to story O. Yeah, this is story O. Now, before you come to story O, let's go to the settings of the foundation. So the bearing capacity of the soil is poor, and that is why we're actually going for pie foundation. But let's do the settings for the pie foundation before we proceed to the pie foundation design proper. Now, so let's go to foundation. Let's go to foundation. So the allowable stress of the soil is 50. So you can see that the soil is actually poor. The soil is poor. All these ones are for pad footings, but the minimum steel bar 16 is okay. It's okay. Then okay, let's leave the top bar. Let's leave it checked because a a pie foundation is having bottom reinforcement and top reinforcement, so you can leave that checked. Now let's go to the pie cap, the pie caps this thing. Now here we are going to input parameters that we have on our soil test in this place. Then we'll also make some references to some textbooks also for some other things that we're going to be inputting. So let's go to the now. You can see that it's telling us that which pie size are we using? Which pie size are we using? So let's go to this. Okay, let's come to story. And let's try and bring out the various axial loads. So to bring out the various axial load of the column, the axial load will give us an idea of the um the diameter of the pie that we're going to select. Is I need you to pay very close attention to this. Like I said, you're not going to see this on the way I'm going to explain how you design and detail the pie foundation. You're not going to see it on any other YouTube channel apart from this one. So what we have here is this is what we have here now. For us to bring out the various column loads. So what we'll do is what we'll go to what review. Once you click on review, we'll click on visual interrogation. Yes, then you click on column display. You click on axial load. Once you click on axial load, then let's pick the service load, which is the dead load and the live load. Let's pick this factored load. Let's pick this. Let's pick this. Then we'll click on OK. Click on OK. So you can see these are the various loads that we have. So what I do now, what the software is going to do is that the software is going to pick the highest combination. The like this one now you have 1186, 1340, 1152, and 1056. So the software is going to pick the highest combination to provide the number of pies for the various pie caps. So for this one now, for this one now, for this one, because of the fact that I'm seeing 1340, I'm seeing 1340, I'm seeing 1149. Let me see if I have 2000. Let me see if I have 2000. So I'm trying to look for the biggest axial load. Yeah, so I believe this one should be the biggest. 1146. This one should be the biggest. So I don't want to have um much pies. It is advisable that when you're designing a pie foundation, it is advisable that you try and reduce the number of pies to the barest minimum. And how do you do that? Is by picking the the pie diameter that would give you the least number of pies. So for this one now, I have 1146. So 1146 now. Now remember that this load are factored. They are factored. So let's go to this thing. Let's go to the soil test report now. This is the soil test report. Okay, for 600 at okay, let's terminate at 22 meters. So for 600 at 22 meters depth, I'm having a safe working load of 408 kilonewton. Now, these ones are service load. These are service load. These are not ultimate loads. Now, what the software recognizes because of the fact that as you are using BS code of practice for the design. Now, what the software recognizes is what? Let's go to foundation. What the software recognizes for the allowable soil stress ultimate strength factor is 1.4. So that means that we are going to multiply our safe working load by what? By the factor of 1.4. So now let's go now. So let's now remember that the safe working load is 408, right? Let's check for the 600 now. Like I said, I'm using the 600 for the design 408. So 408. Now let's go to calculator now. Let's go to calculator. So we have 4 0.08 times 1.4. So we have 572 approximately. Okay. So now let's now go and input our parameters for the pies now. Let's input our parameters for the pies. So let's go to pie caps now. Okay, so my pie size is what, 600 millimeter. That's my pie size. Now the ultimate tension capacity is what, 572 kilonewton. Ultimate. So you need to multiply it by the factor of safety. Now the pie length. Remember I said the soil test report says that we should terminate at either 21 or 22 meters, but I decided to terminate at what, 22 meters. The pie length is what, 22,000, right? 22,000 is that 30? Yes, 22,000 millimeter. So now the spacing multiplication factor between pies and short and long direction. Now you can decide to leave it as default. Yes, you can decide to leave it as default. But if you check some textbooks like that of Dr. Victor Yenuga, as in this, let me show you that of Engineer Dr. Victor Yenuga. So what Dr. Yenuga said was Dr. Yenuga used three. He used three for the. I'm coming. Let me show you what. Okay, so you can see that the distance between pies, he used 3 times the pie diameter. But what the code actually says is that it should be greater than or equal to 2.5 D. It should be greater than or equal to what? 2.5 D. So we can leave it. So we can leave it as default here. Yes, we can leave this as default here. This one you have 2.5. You can leave it. But if you decide to go with 3, it's okay. But it should not be less than 2.5. You can use either 2.5 or 3. But Oinuga used 3. Then distance to the face, short, long distance, you can leave this as 200 also. But when you check some textbooks, what they use is 150 and not 200. So as in, I want mine to be 150. If you check engineer Dr. Victor Oinuga's textbook, if you also check some textbooks on pie caps design, you see that the majority of them use 3. Now, yeah, for pie cap depth. Now, what I do is that I force the software to use the depth that I want the software to use. I don't do limit. Now, for the pie cap depth, what the rule of thumb and the principles we use for the design of the pie cap depth is 2 times diameter. I'm coming. Let me do something for you. So let me bring out the snipping tool. So I want to explain something to you guys about the pie cap depth. So this is what we have now. This is this is the pie cap. This is the pie cap. So we want to know what's the pie cap depth. And remember that the diameter of the pie is what 600, right? 600. Now the rule of thumb that we use for the design of the pie cap is what, is 2 times the diameter of the pie plus 100. Now, when you check various textbooks, you see that that was what they used to actually determine the pie cap depth. So, like this one now, my pie diameter is 600 mm. So we can do 2 times 600, then plus 100. So 2 times 600 is what? 1,200. Then plus 100. So the pie, so the depth of my pie cap should be 1,300 millimeter. Now, what I do is this. I come and force this. I force this to be 1,300. And I also force this to be 1,300. Means that based on the manual calculation that I just did now, I want my pi diameter by the depth of my pi cap to be two times the pi diameter, which is 600 in this case, plus 100, which is what 1300. So you can leave every other thing as default. Leave every other thing as default. So you can include this include effect of the column dimension, include effect of the column dimension here. Then so we can click on what? Okay. So so the setting has been done now. The settings has been done now. So the next thing we need to do is what? Is we need to um input what our pies now. So I'm gonna tell you the number of pies that the software is gonna give me. So we are gonna confirm, and I'll tell you how I'm able to know the number of pies. So okay, let me pick this. Let me pick this. So for this one, there's a possibility that the software is gonna give me two pies. So let's try and let's see. So let's click on this. Start pie cap. Start pie cap. So you see that I'm actually correct. It gave me two pies. Then you click on OK. I'm going to tell you how I know that it's two pies. Okay, so let's see this. So let's look. This one is now should in case the software give me more than what I said, then there's a possibility that the column is having a very high moment. So the software is now providing another pie to actually counterbalance the effect of the moment on the pie cap. So this one now 1340. So this one will be giving me three pies. But if it gives me four pies, then know that the column is having a very high moment. So it actually provided one extra pie to actually counterbalance it. Okay, sorry, I went to go and do. So let's go to what? Insert pie cap. Insert pie cap. So let's wait for it to come up. Three pie. So you can see that I'm actually correct. You can see that I'm correct. So let's see. Okay, let me guess another one for you guys also. Okay, let me guess another one for you guys also. Okay, let me pick this. Let me pick this. This one is what? This one. Okay, so this one is two pies. This one is two pies. So let's insert part 14. This one is two pies. Sorry, I want to go and insert pi 14 instead of pi cap. So this one is two pi. Two pies. Okay, so this one is not going to work because this one is going to be clashing with the it's going to be clashing with the other pi cap. So let me change it to direction one and let's see. So okay, so we can see that the structure is actually coming out very fine. So now you might ask me that how do I know the number of pies that the software is actually going to bring out? I'm going to explain that to you now. So like I said, the way I teach people on my YouTube channel is that I teach them from the first principle. I explain to them in total from the first. Please, it's very important that you get that my template that I use for my structural design is actually very important that you get it because it actually simplifies your work by about 70 to 80%. Also, all you need to do is just to match properties, select similar that's all. Within 15-20 minutes, you're through. So now what I'm going to do is this. Okay, let me explain how I know that it is two pies or three pies. So let me pick this now. You can see that the highest column combination here is what? 923. Now 923 now. 923. So then where's my calculator? Now remember that my safe working load is 572. So you have 9. So you have so sorry, calculator is not working. Okay, so you have 923 divided by 572. So So this should be two pies. So let's see, this should be giving us two pies. So let's insert pie cap. So you can see that I'm correct. So what I'm going to do now is this. And I'm going to select all the columns and just insert the pie caps once. So let's, okay, let's unselect this. Sorry. Okay, let me delete this. As in, I've already shown you guys how to go about it already. So let me delete this. So let me just copy this. Then let me go to, wait. Okay, let's wait for it to come up. Still loading. So let's go to insert pie cap. So let's go to insert pie cap and let's wait for it to come up. Let's go to insert pie cap and let's wait for it to come up. Yeah, it's still loading. It's still loading. So when this is Harvard Consult, this is the YouTube channel. So we are going to be teaching you structural design of steel and reinforced concrete, and the softwares we'll be using are Proto Structure and Start Pro. But the Start Pro is actually going to come to effect by January. So for now, it's going to be Proto Structure. So now, having gotten here, so let's click on design all. So everything has been designed. Okay, it's still actually designing it. So let's wait for it to come up. Let's wait for it to come up. Let's wait for it to come up. It's still designing it. It's still designing it. So let's wait for it to come up. It's still designing it. So please, if you have any question, you can drop your question for me in the comment section of the video, and I can give you my WhatsApp number. So if you have any question, you can also send me messages on WhatsApp, and I will respond to you ASAP. I will respond to you ASAP. Okay, so we are done with this now. So let's wait for it to now bring out the various pie cap. Don't worry about those pie caps that are clashing. Yeah, just don't worry about it. I'm gonna, okay, these ones are clashing. So okay, what we're gonna do for this, so let's click this. Then let's go to properties. Let's go to properties. Then so let's go to, let's go to material. So let's go to option. Let's go to option. So let's change this to direction one. Let's click on OK. So you see that it's no longer clashing again. So which one is clashing again? Okay, these ones are clashing. Okay, so let me see what I can do about this. So let's do this. Let's go to properties. Let's go to option. Let's make this direction one and let's see what will happen. Okay, so let's do this also. Let's do this also. So let's go to properties also. So let's make it direction. So let's go to option. Let's make this direction one and see what's going to happen. So you can see that the problem has been solved. So please, if you have not subscribed to my YouTube channel, we will be dropping series of videos back to back this week because um as in I'm actually free now, so I have time to create good content for you, teach you guys structural design of this, the reinforced concrete and steel structure. So as in I'll be dropping videos back to back for this week and next week. And next week I've already dropped video on the design of the back footing and the template I use for my design. So okay, now let's go to let's go to this in 3D and let's see what we have. So you can see what we have here. So this is what we have. So let's go to review and let's see. So you can see that the structure is actually coming out very very nice and very very fine. So now, having done this now, so let's go to drawing report and let's try and bring out the proper details of it, of this. Try and bring out the proper details. So we'll just copy what we want to work on to the proper details. Then from the proper details, I take it to my template. And this, like I said, the template is going to be available on seller for purchase. So you can place your order for the template. So it actually reduces your work by 80%. You don't have to stress yourself. All you need to do is just to pick edit, match property, select similar. That's all. That's basically all what you need to do. So let's wait for it to come up. Then I just want to take it to AutoCAD, copy it to the template, then we can call it a day. Then subsequent videos we can now talk about the next step about the detailing of this. But this is so you can see the way I explained the design of the Pi foundation from first principle, how I did the explanation in total. I'm not somebody that believes in the fact that I know how to use software. No, I'm somebody that believes in the fact that you must know what you're doing. You must know what you're doing from first principle. So okay, let's wait for the product details. I don't know. Okay. As in, I wanted to say that I don't know why the product details is not coming up, but okay, okay. Okay. This is just 27 minutes. So let's see. Okay, let me pause the video and fix the issue. Okay, it's already loading in the background. It's loaded in the background. So we'll just copy it to the product details. Then we'll name it as Pi Foundation Design. Then we'll take it to the template. Then we can call it a day there. Then subsequent videos I would teach you guys how to how to detail it, the tricks that you need to know to detail it. Yes, then cut section and what have you. So the next thing that I'm going to teach you now is a raft foundation, because as in I've taught you for pad, I've taught you for Pi foundation now. So the next thing we need to know now is how to design a raft foundation. So now this is auto generate details. So let's click on auto generate details and let's make sure that it is on 50. Let's make sure that it's on 1:50. Yeah, so then you can draw this and let's drop it here for it to drop. Okay, it's actually a lot. I should have just brought out the pile, because that's what I want to show you guys. uh, that, that's what I want to show you guys. Okay, it's still loading. Okay, let me pause the video then, or let me leave it. Let me leave it. Let's leave it and let's see. So we just gonna we are just gonna export it to we are just gonna export it to the software. Once we export it to the template rather, then we'll be calling it a day. Please, if you have not watched the video that I just talked on part footing and detailing, please kindly go to my YouTube channel and watch it. It is very, very important you watch it. I taught you guys how to design a part footing, and I also taught you guys how to detail it using the Siapa template. That is the template. Now, the template contains a raft, it contains a pile, it contains a pad, it contains strip, it contains how to detail slab, beam, and everything. So, but I'll be teaching you guys how to use the template. So for tomorrow now, the videos that I'll be dropping for tomorrow's is just basically gonna be on the template. Just how you guys are gonna be able to use the template for your detailing and this thing and whatever you guys want to use it for. And once you can buy the template, you have access to ask any question regarding the template. So let's wait for the software to generate all the structural elements. Then from there, we can call it a day. Then tomorrow, then by tomorrow, I'll just be working on the template. So just show you guys how to detail beam, how to detail slab, how to detail column, and stuff like that. So okay, if I at noon I would have just okay. Let's just um let's just leave it let's just leave it for it to bring out everything. Let it bring out everything. So it's gonna bring out the reinforcement details of the parts, everything. So let's wait for it to bring it out. Then from there we can actually proceed to call it a day. Um we make sure that we teach you structural design from first principle, and we teach you everything that you need to know about detailing. So like I said, we'll be starting the Start Pro as from January, but for now let's just focus on brutal structure. And please, if you have any question, please drop your question in the comment section, and maybe as time goes on, when I open a community for my subscribers on WhatsApp, then if you're working on a design and you have any challenge, be it for Prota, for AutoCAD, for anything, then you can just drop it. You can just drop it on the platform, and immediately I'm going to give you answers to it. And if you want, also I can drop my personal phone number for you. Okay, I think it's still loading. I believe it's still loading. It hasn't. My mouse is not functioning. My mouse is not functioning. Okay, so we are done. So let's save the drawing as let's just save it as Pi Foundation. Let's save it as Pi Foundation. So let's save it as Pi Foundation. Let's wait for it to save. Let's wait for it to save. Yes. So it's still coming up. It's still coming up. Okay, so it's done. Okay, it's still coming up. It's still coming up. Sorry, if I knew I would have just Okay, it's still trying to rename it. I just want to show you guys just how I was able to just copy to the template, and that's all. I mean, we're already through with the design of the Pi foundation already. We're through with the design of the Pi foundation already. So I just want to show you guys how I was able to export it to the template that I used for my design, and then it's taking time because the structure is much is big. It's actually a five-story building. Okay, we are done. Let's let's export to AutoCAD now. So let's click on export. So let's click on export. And let's wait for it to export. So it's exporting. So let's wait for it to export. Now the reason why I'm trying to take my time because some people don't know how to export to AutoCAD, and um so this is an avenue for you to see what I'm going to do. So I'm just going to copy the layout of the pile. I'll copy the layout of the pile. I'll copy the reinforcement detail of the pile. Then I'll copy it to the template. Then the video. Then I'll stop the video. Then subsequently, subsequently we can now continue from there. We can now continue from there. Okay. So this is the pile foundation. So let's click on it. Let's click on it. Let's wait for it to come up. Let's wait for it to come up. Let's wait for it to come up. Um. Okay. So it's loading. It's loading. It's loading. Okay. So very good. Very good. So this, like I said, this is what I need. This is what I need. So let me copy this. Yes. Let me copy this. Then let me check this also. So I will be explaining this in subsequent videos. But let me just copy this. So I've selected this. So let's do Control C. All together. So let me go to my template. So let me go to my template and copy to my template. Let me go to my template and copy to my template. Where is it? See alpha template. Okay, this is it. This is it. Okay. So um so let me just paste it here. Okay, this is it. Can you see? So so let me copy this. Let me copy this and bring this here. So the idea is to make it like this. So the way it's rough like this, the idea is to make it like this. Okay, as in I have a flat batch already. So this is the idea. This is the way it is now. So we are going to tweak it and make it like this to suit what you have on the template. So thank you very much for staying tuned, and I'm gonna end the video now because I already have a flat battery. Thank you.